Right. Everyone can see the screen okay? Right, folks. So you haven't got a level 2 GCSE in computing. So there's a bit of a gap in some of your knowledge. But before I introduce the tasks you haven't seen so far, are task 5 and task 6. Let me just briefly mention task 5 to you. I think it's worth you knowing about that. I don't even bother with that. Tasks 6 and 5. Where are they? There you go. Programming. Fundamentals. All right. The written task entitled task 5, is about these particular criteria. Dealing with syntax and logical errors, and using consistent indentation and appropriate comments. Oh dear, spelling error. So number 1, provide 3 reasons for the importance of testing. Number 2, provide 2 syntax and 2 logical errors you found in your code. I'm sure you would have lots of errors along the way. You remember how you corrected them to debug them, how you found out the error and how you corrected it. Syntax errors, as a little hint, are errors in the spelling or code format. Logic errors are errors in your application design and make it behave differently. So if you typed in something wrong, like a tag, for example, that's a syntax error, so an error of language formatting. Logical error is, for example, say you do a mathematical function and rather than a plus, you put a minus. Okay? You just use the wrong logical approach to it. And often it's like, it'll still work, but it just gives you the wrong output. You should look at definitions of these both and try to look to explain them before you look at these errors and show exactly where they were and how you fix them, okay? Finally, produce an export list of your code for one of your programs, demonstrating how you formatted and included comments and appropriate indentation that's related to this particular one here. Okay, good. Is that all right? That should be okay. I'll do something on testing next week anyway, right? Just a bit on testing. Yeah, why testing is important. Not to be a long section now. Now, next up, task 6 is hidden away in the document over here. Quickly going to show it to you. There you go. Right. I'll bring it up again in a minute. Let me explain this first. Program design. Okay, Remy, are you with me as well?
No.
Let's finish the last message bits. I need your interaction in this part.
Okay.
Thank you. Right. Just say I'll be back. BRB, yeah? Okay. So, program design. When we first look at coding, there are some stages before that. I mean, some of the tasks we've done so far have been quite straightforward. 1, 2, making the matrix. 3 gets a bit more complex. 4 is quite straightforward. 6 is going to require a more complex approach as well. So, what I want to introduce you to is a few concepts. Algorithms. So Hale's going to feel so bad for missing this. Pseudocode and flowcharts. Those are like construction elements of building programs before you get going into them. So some of the sort of terminology here. An algorithm is a plan, a logical step-by-step process for solving a problem, normally written as a flowchart or pseudocode. Okay? It's really to help you guide your thought process, you know, to keep asking, what if you try things out in different ways, solving a problem in different approaches, and seeing what is the most, getting the same outcome, taking different approaches, but what is the best way, the most efficient way of coding something. This sets the scene for the more complex tasks you've got to do. So when you're designing the algorithm, it's more than one way of doing it. You know, the big picture, what is the final goal, where have I got to get to at the end? And then what are the individual stages? What hurdles have got to be overcome on the way to reach the goal? So before you do an algorithm design, you've got to first understand the problem. And a nice, simple way of breaking apart this, okay, is simply in 3 sections. What are the inputs into the problem? What are the outputs of the problem? So then you know your kind of incoming and your outgoing. And then what instructions have got to be carried out in between the input and the output. And there also can be termed process or program code, whatever it is instructions. What decisions have got to be made in the problem? Are any parts of the problem repeated, like going through a loop? Once you kind of get that right in your mind, then you can look at designing the algorithm itself. Designing the algorithm is usually done using something called pseudocode. And most programming languages, as there are many, have specific syntax, so the program can run properly, whether it's Java, PHP, Python, whatever it is. Pseudocode is not a programming language itself. It's a simple way of describing a set of instructions that don't have to use specific syntax. Common pseudocode notation. These are the kind of language constructs you'll use for designing pseudocode. Input. What is going on out there? Oh my God. No, the horn is going off in the car outside. God. Okay. Forehead on the wheel as usual.
Yeah, exactly.
Oh my God. Oh God. Okay. Input indicates the user will be inputting something. Output, what will appear on the screen. While is a loop iteration with a condition at the beginning. For is a counting loop. Repeat until a loop iteration that has a condition at the end. Repeat this until x equals 10. Sorry, folks. Worst possible timing, that is. Oh, right. If then else. So if something, then something, else something else. A decision in which a choice is made. And normally we indent where we have selected iterations. Here's a little example of one of these pseudocodes. Okay. So here's a program that asks people what the best subject they can take is. This is how it would look in pseudocode. This has got a repeat. Okay. It's quite a funny program, this actually. Repeat output. What is the best subject you can take? The user sees this. Input. User inputs the best subject they can take. Store. The user's input in the answer variable, so they put in the value, so they put physics in. If the answer is computer science, then the output is, of course it is. Otherwise, the output is try again. And it'll keep on doing this until you get the answer for computer science, which is clearly the best subject, as far as this is concerned. And there you go. Right, a pseudocode there. Now, pseudocode is written like this, okay? But also you can do it in a visual way. Flowcharts. A flowchart is a diagram represents a set of instructions. Okay, so those instructions you saw earlier on can be turned into what we call the like it's a data flow diagram or a flow chart. These can be used to construct the step-by-step solution. Is your hand up there?
Yes.
Yes.
Is it pseudocode because the user has to guess the answer?
No, that's not what it really means. It's more like it's like a way of planning your program out in English, natural language. That's all.
Isn't that normal code?
No, well, this is not PHP syntax, is it? If I put this in my PHP program, is it going to run?
Cool.
It's not, is it? But if I give it to a Java programmer and a PHP programmer and a C programmer and whatever Remy's doing over there, right? Facebook programming it, right? Then one of those can pull it off. Yeah. Okay, flowcharts. So a diagram with a set of instructions, and this is how they're done. There's like a little bit of a grammatical law to this. Okay, here's some of the common symbols of a flowchart. Let me zoom in on this actually first. Here's your big symbols, right? You got here start and stop, beginning and end points from the sequence. Process is like a little square, instruction or command. Decision is a decision, either yes or no, or diamond shape. Input, output again. You've got input by computer, output is signal sent from a computer. Connector is a jump from one point in the sequence to another. Direction of flow, which way does the instructions flow? Here. Hello, Moe. I know you had to go. I've filmed this, okay? And I've been going over some of the theory, so you need to watch this video back. I'm not going to say this again, all right? Okay, don't worry, you'll get a video clip in a minute on WhatsApp. Yeah? All right, finally, as you get to the end of this, let's go over some of the kind of instructions here. So these flowcharts will show you start and end, the order of the sequence of instructions, the points where inputs and outputs occur, the points where decisions are made about what to do next, and you use these commonly British standard symbols, right, to show your flow of your program. Here they are. Here's an example of such a program, a flowchart. Looks like this. The same thing we looked at earlier on. This is how it would be shown in this format. Start, input, and you see this loop here. If it's no, you go that way. If it's yes, you go this way, and then stop. This is the decision. That's your input and output. There's your start and stop. There's your arrows with the flow of instructions of where it goes. Just watch me, please. Okay. So does that all make sense, folks? Flow.
Follows that some sort of loop.
Sorry?
Is it similar to loop like for
This particular part, the loop is here. That's the only looping part, isn't there? Right? This loops around again. If you keep saying no and keep getting the wrong answer, if you keep typing the other subject, like biology, you can keep going this way, aren't you? Until you get computer
So
science.
you get down, so you go for it.
This is a repeat until loop, I'd say, most appropriately for this, or we call it do while. Do something in PHP while something. Can be done in many different ways, actually, this approach. Again, you can explore different approaches using this language here. There's different approaches you can take in that situation.
Yeah.
Okay, now the programs you've got, I talked about task 5 is just written. Once you can, you can do pseudocode on. If you haven't got done task 3 yet, for example, grade assessor, that's something you can apply this on immediately. I recommend you do so. Okay, it's quite a sophisticated one. So who's not done task 3 so far? You guys, yeah? So you can look at that.
Okay.
Yeah. Good.
Yeah,
Task 3, grade assessor. Yeah.
This is that's the one. It's just so much, really.
That's why we're doing
Too
this
complex,
today.
isn't it?
Grade assessor.
Yeah, super
Puts
hard.
it super hard. If the input 5 grades.
Not so hard. It's not so
Let me
hard.
just explain this
It's not
task.
so hard. It just needs
You're a
it's
bad
need
boy.
more understanding of PHP.
Well, yeah,
Now,
but
good understanding, you'll be confident. You'll be
Right.
able to-
that's why pseudocode is important. Pseudocode, what we've been doing now is showing you how this is constructed. Okay, so you watch the video in a minute. So the grade assessor task, I'll just explain it once more for a lot of you who haven't done it so far. Yeah, we can look at that now. Okay, and how we approach it like this. So what you should try to do is try to look at that program first as pseudocode, do a little data flow diagram for it first, and then code it. Okay, I'll give you some basic suggestions for how you would approach this task. I will give you some pseudocode already to begin with. Let's find the program. This one's all right. Task 4 is read and write. A lot of you did this in class with me, actually. This is quite straightforward.
Yeah,
That's reading and write. Yeah, you okay with that one?
we finished this one.
Yeah, read and write and files, we did it together. Right? So Joe and Richard, I'm not sure if you're here for that one.
I finished this one.
You were?
No, I wasn't.
You weren't, Richard? Read and write. Maybe not here for the file management. The rest of you were here for
You
that.
can help them out.
There's some resources, so it's actually quite a straightforward task. Now here we go. There's a code challenge here. Comes out in a minute. Here's a task 3. Okay? Now I do say here to do mathematical functions, selection commands, and logical operators are what you have to use. Here's your general pseudocode. Now, this is one approach to the way of doing it. I'm asking you to use a function here. Okay? So what will happen is you have one page which takes in 5 values. Great.
Okay, done.
It posts it to the other page, which does a calculation, giving you back the percentage average of those 5 grades.
The other page does the calculation.
Yes.
But don't forget the page that you put the page that you're inserting the grades. It must have a data validation.
You can do that in a number of ways. A number of ways it can be approached, either through the loop you use, or you can use it through something in HTML5, which allows you to specify a range. Much easier approach. That's what I'm going to say about it. HTML5 has a range, minimum, maximum, and required. Just in the form. You can do it all on the client side. It doesn't require server-side programming. Okay? If you want to do it on the server-side programming, you've got to think about the pseudocode behind it. It's something like if each variable is in a different box, like we call it grade 1, grade 2, grade 3, grade 4, grade 5, yeah? We'll only do the calculation if the grade 1 meets the requirement and grade 2 meets the requirement. If all of them meet the requirement, then it will process it. You've got a choice. Do I do it on the client side or on the server side? I don't mind.
I'll try to do it in HTML5.
Then you've got to find out how that's done, but it's just very straightforward on HTML5.
Just give me a.
No, I've already said it to you. HTML5 required function on the form, minimum and maximum. I'm not going to say the code to you, am I? No. You need to pursue that. Right, okay. So, Here's a pseudocode here. So I'm saying take 5 grades and do the average, get the answer back. Okay, and this is one approach to pseudocode here. This is one approach to it. Okay, calculate the average grade, display the result with a simple message. But later on, to extend this task is to do with getting the results into a table. Okay, so you've got all the grades in front of you. Student results are as follows: 30, 40, 50%. Giving them a grade. Okay, what the grade is for a particular result. In like maybe at 37% is an E. You will devise how you want to do that. Okay, so look up some grade boundaries. So universities have standard ones, and the user gets back all the results as grades and also an overall average and a grade average as well. So I got a 75% average. My grade was A, for example. That's it. Simple input.
Easy.
So think about it: input, process, output. Use it as pseudocode. Yeah, do it in pseudocode first. This is not the only way to do this. There are many ways of approaching this.
Do the pseudocode first and then the
Yeah,
non-pseudocode.
pseudocode, diet flow chart, and then code it.
And then the anonymous one, and then you finish.
Yeah, that's the right way of doing it. Okay. So those of you who are going to attack that now can start doing so. Start building that up. If you haven't done yet, so I'd say maybe do grade assessor, and then those who haven't done grade task 3 at all, start that now.
Yeah.
And then do task 4 after that as the original sequence I've got. Those of you who finish task 5 as well, right? I'll introduce task 6 to you so you can see it. Task 6 is a higher grade challenge.
Write 10,000 words.
No, never. Right, so who's up for task 6?
Oof.
Remy? I'd like you to stop Facebook, please, in a moment. Just minimize it, yeah, with me, please. So I can just go over task 6 with you.
Okay.
It's the moment you've been waiting for. Just tell the person, my tutor's now told me the most important thing about my task 6. And I'll be right back to you soon. Thanks. Right. You good, Remy? Can you leave Facebook for a few minutes, please, for me?
I'm counting.
Can you abandon your many girlfriends?
You've got 1.5 left.
Excuse me?
You have 1.5.
I'll extend. I'm getting with 5 minutes, mate.
You can put one eye, Facebook one eye on the screen.
So look, I'm quite a nice teacher, Remy. Some teachers won't accept that at all, you know. All right, so just I don't want you to miss out
What
on
are
it.
they going to do? Kick me out from the class?
Well, yes, they can actually.
Oh,
Well,
that's not actually a problem to me.
that's the problem.
Sometimes the benefit. Feel free.
You might, but that's not my style. Remy, I want you just to watch this, please, okay? And choose one of these. So, because you've not seen this bit below here, this bit. So, the final task is open-ended, and it's a high-grade assignment. I'm letting you choose one of the following options for a program. One is a blockchain algorithm to encrypt a number into something secure and then enable the decryption of it with some kind of management of a password. Yeah? Not sure how you're going to go about doing that, but it's allowing you to create a blockchain of some kind of a number, make it encrypted, like a special code perhaps, and only a password can unlock it. Okay? Second one, this is yours, Farzan.
Yes.
Simple sound launch pad. Yeah? Various sound effects generated from different keypads being pressed in real time. I'm only using number keys for this. You can play the sound files concurrently by pressing all of them. You also can mute and manage them. Okay? Challenging, definitely. Third one, a grade manager. So extending the task on grade assessor, here we have an extension. And what happens is that not only can the tutor put some grades of various classes for various students. So what you say, you give a student's name, like Joe, you put in 5 grades, you put in another student's name, like, you know, Farzan. Put in another, the same grade, same subjects, and when you push the button, the student can see that kind of what grades they got and then their average grade. Yeah? Okay, this extends the other one you've got already. Number 4 is a simple chat box, a bit of artificial intelligence here. You simply, it's a chat bot. You ask it some, like you get on the websites like Vodafone. You ask it a question, and it's like, you know, what is my plan? And it gives you back some web links or some kind of AI answer. Yeah? Student questions, FAQs, where are the loos? You know, what do I do if there's a fire in the class? That kind of stuff. Yeah? Okay, you can make it quite funny as well and put some funny words in there. It's quite cool for artificial intelligence. Number 5, your own idea, your kind of concept. So you can suggest me something and I'm happy to accommodate it if it ticks the boxes. And here's what you need to do to get a high grade on this one, right? These are the kind of things I expect to see. I need to use pseudocode, use diagram, show your input, process, output, using functions, working presentation of code, answer of questions on how code works. I'll ask some questions verbally. Well-presented code with good variable identifier names. You can't put into dodgy values, so I can't break it or crash it. Reusing the code, so don't repeat stuff and do it inefficiently. Do some research and reading, and a good-looking interface, graphic user interface like a GUI, with styling in some appropriate menu system. All right. Ideally, if you put all your programming stuff into one big menu, every task is like a little menu, right? Task one can go inside it. There's a good way to present your work at the end, all your work, yeah? And you have your 6 program codes, whatever they are, and you can click on a link and I can see a full menu of how to get to stuff. Yeah? So some of you are going to be, I think, is it Remy? Are you rolling for 6?
No.
I see. Okay then. Tim, you might, all of you might look
You
at
have a
this.
6.
Yeah,
So
that's
we work on
later. Let's get task 3 cracked first for some of you. And the code
Task
challenge.
3.
Well, let's see. Let's talk about it. What's up.
I've got the, I know now how to do the,
Yeah.
how to do the data validation, and now I need to move now to the,
Yeah, so step at a time. And look, we need to look at the kind of deadline for this module on how we want to do this so we don't get too pressurized by it. Here's how it looks for you folks, yeah? Like I said, you've already got 30-something credits already now, yeah? If you've caught up with everything. So if this is due in, further work due in next week, it's another 6 credits. Programming's down here somewhere.
That's all distinctions.
I know, yeah, that's true. I know. So programming, I mean, I've got to be fair on this one. What do you think is wise for programming, given other deadlines?
I think it's.
Should we go for May programming?
I think it should go the furthest. I think it should be the last
There's
one.
2 programming modules, Murray. This is the other programming module that comes after
Yeah, probably.
in Easter. I think May will be good.
Yeah.
Because May's a month, you haven't got anything else.
Or made for what? For this?
Programming fundamentals,
Finish it off.
yeah. Because then you've not got it all coming at once. Because like June's busy with like that one. This is complex, you know. That's
Okay.
heavyweight database-driven web pages. It's PHP next level up. You're talking to databases, fetching data. You'll be all right. Visual programming as well as during around that time.
Spend the whole day in the library trying to find out how to.
So I think May should be better for this programming fundamentals. Maybe not like early May, but maybe somewhere in the middle
Yeah.
before half term.
20th of May.
Yeah, that sounds good. Before half term is good.
Hmm?
5th of May. It's my brother's birthday.
The middle.
Yeah, okay. Yeah, we've got a few weeks to go till Easter, like up to there, right?
Yeah.
And you've got a break.
2 weeks.
And you come back around somewhere there.
16th.
Got a lot of time, you know. It's got a lot of time. I think you might be chugging along quite quickly.
Chug it and hug it.
Well, so let's see how it goes. I mean, task 3 we should get done probably by next week, I would say. Yeah, task 3 is really needed in by next week. Task 3 we've done already. So if task 3 is during next week,
Task 3.
I would say
Seriously.
another couple of weeks. Yeah, some of you might finish it before that. Okay. Okay, I'll look at May and work out a week in May when it's fair. Oh. Okay. Right, folks. Any questions on this? Any questions? Right. So if not, task 3 is where you pick up next, most of you, and then I'll come around and help out. Yeah. All right.
What's that?
What's that your keyring? What's that green?
Is it task 4?
Oh, channel.
The task 3, the last one.